Okay, today we're just going to continue with our previous lesson, trigonometry equations, and we're going to go day 2, and you need to have your formula sheet near you so that you may have to do some manipulation with identities here. So our first one here, we do have an issue for sure on number 1. We're again going to solve the equation on the interval theta is greater than or equal to 0 but less than 2 pi. Okay, that's a typo again, recall. So when you look at this, we go, okay, how do we convert? We have cosine and sine, but no squareds. This is like very difficult. But how many terms do we have? We have 4, right? Well, whenever we have 4 terms, the first thing we should think about is factoring by grouping. And in this case, it works real nice. Because if I take out cosine here, I'm left with 2 sine theta. Oh, I can take 2 cosine out, can't I? I can take 2 out, 2 cosine. And I'm left with sine theta minus 1. So I rewrite that over here, sine theta minus 1. And then I divide these last 2 terms. 1 divided by negative 1 is minus 1, and there's my factors. 2 cosine theta minus 1 and sine theta minus 1. So it wouldn't do you any good to switch sine and cosine to like x and y. It really wouldn't. It's just as easy to do it that way. Take out a GCF, 2 cosine. You're left with sine theta minus 1. Well, you just rewrite it, sine theta minus 1. Group it and divide those last 2 terms. Put the minus 1 where it goes, right here. And then there's your factors. Okay, and then we split them up. 2 cosine theta minus 1 equals 0. And sine theta minus 1 equals 0. So sine theta equals 1. Take the inverse sine of that. When is sine 1? All right, there's only one place, 90 degrees. Pi over 2. Cosine would be 1/2. Take the inverse cosine. Now you have to ask yourself, when is cosine 1/2? Cosine is 1/2 at pi over 3 and 5 pi over 3. So the solution set for theta in this case would be pi over 3, pi over 2, and 5 pi over 3. So that's a factoring by grouping problem. Okay, number 3 is a little bit different. It is definitely a factor problem because you have cosine squared and cosine and you had 3 terms. A is 2, B is negative 5, C is 2. This is where we want to split the middle term. So A times C got to add up to B. Well, B is negative 5, A times C is 4. What times what gives you 4 and adds up to negative 5? What times what gives you 4 and adds up to negative 5? Well, that's easy. Negative 4 and negative 1. So I think most of us like to write it this way. So I will write it this way with an x instead. So we'll let x be cosine. So now if we're going to split the middle term, we're going to split negative 5x to negative 4x minus x. So we split the middle term and we factor by grouping just like we did before. Well, what comes out of the first? 2x. What's left? X minus 2. So x minus 2 we rewrite. Then we divide these 2 terms, the last 2. 2 divided by negative 2 is negative 1. There's our factor, 2x minus 1 and x minus 2. Now I can go ahead and solve these. X equals 1/2 and x equals 2, right? And now we can just change our x's to cosine. So we're going to have cosine theta equals 1/2 and cosine theta equals 2. Now we have a problem, do we not? Yes, we do. Is there any way to make cosine 2? No, the most it can be is 1. So then we don't even have to worry about that. So we're going to do the inverse cosine of 1/2. So theta is 1/2 again at pi over 3 and 5 pi over 3, and we're done. Number 2. Well, let's replace tangent with x. Now you're telling me you don't know how to factor that? It's a difference of squares. I'm pretty sure you do. X plus 1, x minus 1, which would be tangent. So you get 1 and negative 1 for our x. So tangent theta equals -1. Tangent theta equals +1. Now you could do it this way. Okay, and then take the square root. So tangent theta would equal ±1. It's the same idea. You can use either way you want to do this. Now take the inverse tangent of both sides. So you have to ask yourself, when is tangent -1 and +1? It's all the multiples of pi over 4. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All 45 degrees. Okay? So far, looks like day 1, doesn't it? Pretty much. Now here's a couple problems that may be a little more difficult. 4 sine squared theta over 3 equals 1. Well, let's just solve this like we normally would. We divide by 4. Okay, that's 1/4. We take the square root, right? So we'd get the sine of theta over 3 equals ±1/2. Say what? Yep. Square root of 1 is 1, square root of 4 is 2, and since we did the square root of both sides, we have to do the plus or minus. Now this theta over 3 can't be dealt with yet until we take the inverse sine. Ask yourself, when is sine 1/2? When is sine 1/2? Well, sine of 1/2, or the sine is 1/2 at pi over 6 and 5 pi over 6. So we have 2 answers there. Now we're not finished with those. Notice it's theta divided by 3. So now you have more equations you have to solve. So you can cross multiply these, or you can just simply multiply by 3. So theta would equal 3 pi over 6 or pi over 2. That's one answer. The other answer would be 15 pi over 6. What's 15 pi over 6 reduced to? Let's see, 3 goes in there 5 times, 3 goes in there 2 times, 5 pi over 2. Well, 5 pi over 2 is bigger than 2 pi, so that's a redundant answer. So far, our only answer is pi over 2. Okay, I should put a bar in between these to keep them separate. Okay, now we got to do the other side. Theta over 3 equals, now when is sine -1/2? Well, 7 pi over 6 and 11 pi over 6. Now again, we're going to do the same thing. Theta is going to equal 21 pi over 6. Reduce that. Let's see, 3 goes in there 2 times, 7 pi over 2. Well, where is 7 pi over 2, since that's outside of our domain? 7 pi over 2, let's see, that's 3 pi over 2, isn't it? If we go around the circle. So 3 pi over 2 is going to be an answer. Theta equals 33 pi over 6. So let's see if that's right. Let's see, that'd be 11 pi over 2. So 11 pi over 2, let's see, 4, 8, it'd be 3 pi over 2 again, so that's redundant. So our 2 answers are pi over 2 and 3 pi over 2. Now before we commit to 3 pi over 2, let's put it in there and see if it works. 4 sine squared 3 pi over 2 over 3 equals 1. Does it equal 1? Let's see. 4 sine squared let's see, that would be 3 pi over 2 times 3 over 1/3. And the 3's would cancel. It's pi over 2 then. Pi over, what's the sign of pi over 2? 1. 4 times 1 does not equal 1. So that doesn't work. So these are the only two answers we got to concern ourselves with, and they're outside the domain. So let's see if pi over 2 works. So 4 sine squared, oh, I know it will work. 4 sine squared, pi over 2 over 3. So that's pi over 6. Sine of pi over 6 is 1/2. 1/2 squared is 1/4. 4 times a fourth is 1. So there's only one answer here. That's it, pi over 2. 3 pi over 2 did not work. We proved that. Oh, I forgot to square this. Oh, no, it worked, didn't it? No, pi over 2 is 1. 1 squared is 1. It's 4. So that does not work. So that's our only answer. Confusing myself here. You're thinking, God, if he's confused, how confused am I going to be? You're all right. We'll figure this out together. Okay, the tangent of 2/3, or 2 theta, equals 1. Okay, so to do this one, we're simply going to figure out, okay, when is tangent 1? So we're going to take the inverse tangent of 1. So when is tangent 1?